Hello, everyone, and welcome to another episode of Building Drawing 101. In this episode, I will show you how to draw elevations of a simple building. Alright, so this is a simple two bedroom building, rather. Alright, so this is a 2 bedroom dwelling. This is the front bedroom. This is the bedroom to the back. This is the bathroom, as you can see based off the fixtures. Kitchen, living and dining, and the front porch. It's a very simple building. Okay. In order to draw the elevation, or elevations rather, we need the floor plan and we need the roof plan. Or we need measurements from the floor plan and we need measurements from the roof plan. Okay. So let us establish something here. Think of building drawing as orthographic drawing. You have different plan views. You have the floor plan, you have the foundation plan, you have the roof plan, you have other plans such as the side plan and the electrical and drainage plan. Those are all plans like what we have in orthographic projection. We also have the front view and the end view, just like in orthographic projection. However, in building drawing, we are going to draw multiple end views, and unlike in regular orthographic projection, we also know about drawing the rear view. Right? For this specific exercise, I'm going to draw only 2 views, but you can, based off what I will demonstrate, you should be able to draw the other 2 views of this building. Alright, so I'm going to draw the front view and I'm going to draw one of the side views. Alright, so let's copy this building. Since you're in AutoCAD, we can easily transfer measurements instead of measuring from scratch. So this is what I'll use for my floor plan, so I'm not going to mess this up here. So I'm going to just copy another one. Okay, and I'm going to establish some levels. When we talk about elevations, we are talking about the front view, the side views, and all those views you can know the height of the building. The plans will not show you the height of the building. So we're going to establish the first thing, which is the ground level. So I'm going to draw a line. This is representing the ground level. I notice I've drawn it under here. I'm going to also project downwards the edges of this building. This line is projected downwards in line with this edge of the building. Alright, so this is my ground level. Alright, the next level that I'll project is my floor level. So this is representing outside, and we all know that once you step inside of a building, the level tends to go up. There are cases when it goes down, but for the most part it goes up. And I'm going to use a standard measurement of 300 millimeters. So I'm going to select the offset command and offset 300 millimeters upwards. And this level will be my ground level. Alright, I'm going to put this in another layer, another color. From the ground level, I will now establish what we call the lintel level, or the lintel height. If you notice, for most buildings, or for a lot of buildings, the door and the window, the doors and the windows are on the same height. Meaning the top of the door and the top of the window are normally on the same height. So we are going to establish that level. We call that the lintel height, because lintels are built over doors and windows, and they will normally be built at that height. So that height varies, but it is most often 2,000 millimeters. In some cases it's 2,100 millimeters, but I'm going to stick to 2,000 millimeters. So that's the offset distance that I'm going to use. So that's 2000 millimeters from, and please note that I've offset this from the floor level and not the ground level. And the next thing I'm going to offset is the height of the wall from, again, the floor level, the height of the wall. So let's go ahead, offset, and in this case I'm going to use 3000 millimeters, that is from the floor level. The minimum height, the minimum this height can be is 2400. Well, I was going to say 2700, but I've seen some cases where 2400 millimeters are used. For 2400 millimeters, that's approximately, that is 8 feet. 2700 millimeters, 9 feet. 3000 millimeters, 10 feet. So I'm going to stick with 10 feet. Alright, so once I have this measurement, I can now proceed alright. So what I normally like to do, alright, so this is representing the height of the wall. Now I'm going to need the roof. Alright, since this roof right here is a straightforward roof or a rectangular building, the triangular portion can easily be drawn. So this is what I am going to do. I am going to select my angle for this roof, and in this case it's 30 millimeters, 30 degrees rather. And from this point, I'm going to draw the angle, and from this point I'm going to draw the angle, and they meet right there. Then I'm going to look at the roof plan, because these points, this is not the height of the roof as yet. We have to look at the height, the additional height that the thickness of the rafters or the width of the rafters add. So the hip rafter here adds an height of 150 millimeters. You're looking from the plan view, you're seeing the 50 millimeters. From the elevation view, the 150 millimeter, that portion will be taken into consideration rather than the 50. So we're going to offset. Alright, another thing that we're going to take into consideration is, let me all put these in construction lines, is the overhang. So from the walls of the building we are going to overhang. So I'm going to offset 450 millimeters from these lines, and that's the overhang. And so as to not get you confused, I'm going to also change these lines into construction lines. Alright, so this is what we're going to do next. We're going to extend these lines, these rafters, we're going to extend these rafters. Once you have done this, we can now proceed to delete the lower portion. We can just turn off the layer, but I'll just delete it. This is to establish the true height of the roof. Alright, and at the side of the rafter is the fascia board. So this is what I'm going to do. You will see the fascia board at the front, so I'm going to connect this line here. So it is representing this fascia board at the front, and if you look at the measurement, it's 25, that's the thickness. That's not the measurement that we are going to need. We're going to need the 200 millimeters. So we're going to offset 200 millimeters downwards. So we can draw this line, we can draw this line, And I'm going to now brighten these lines. So this is the actual height of the roof. I can now proceed to trim and then remove. So this is the height of the wall, but due to the overhang, the roof appears lower than the height of the wall. Alright, so that's not an issue. We're going to keep this here. Alright, so far so good. We can bring this in a bit. I don't like to see it that far out, but yes, well, you have to have it hanging off a bit to show that it's the ground. Alright, after we have gotten the shape of the front of the house, we can now proceed to insert the windows and the spaces that you're seeing. Let me start with the simpler part, the window. So I'm going to project every, let me change my layer. Alright, so I'm going to project the windows downwards, and I'm going to project them onto the lintel line, this line here, and that's the height. That's where the windows will stop. This line here will be projected all the way down because it is not a window, it's an opening, so the opening goes beyond the height of the window. Let's deal with the window first. Let's deal with the window first. Alright, a standard window, the height of a standard window from the lintel, or the depth from the lintel height, is normally 1200 millimeters. So let's draw that. And you can brighten that. So basically what I've done so far is project the measurements from the front of the building, and I've established the different levels going up, and established the shape of the roof. And if you notice, I've used 45 millimeters for this, 45 degrees for this, but I've used 30 for this. Now this angle can change, this angle will not change. The angle used to draw the plan, because on the plan view you will see this is just showing the angle between the different faces, while this is showing the slope of the roof itself. So the slope can change while this remains the same. Two different angles of viewing the house, one from the plan view, one from the front view. So you have the window. I am going to draw this. I'm going to continue drawing the window so that it looks like a window, but for now let's look over this part. This opening goes all the way to the ground level. So I'm going to draw a line from here. Hold on, let me switch back to the outline layer. From here to here. Now, if you know the height of the opening, then you have to bring it to the height of the opening. So you will determine the height. So I should have brought this here. This will not be the overall height. My intention is to give it some arches, but the arch will start here and go up and come down. It will go up again, then it will come down. Alright, if you notice here, there are two columns, so it depends on what you have here. There are some columns here, some fancy round columns. So with this, I'll establish the center of the column and drop it there. I'll also establish the center of the column again. Now the column design is totally up to you. I'm going to draw the first column, and then I'm going to transfer the measurement to the second column, or the drawing. So the column will be here. The columns that I have, they are 200 millimeters. So to each side of the center line I'm going to put 100 millimeters. So this is the column, and you can design it how you want it. I'm going to just keep simple, and I'm going to do this. So this is up to you. Well, this is 300, this is 150. So very simple design, very simple. I'm now going to copy this column from this center point to this center point. Alright, I think I want to leave these lines for now. I'll just turn them in construction lines. And as you can realize now, you'd have to trim away this part and this part. So the column is overhanging a bit. Shouldn't be any major issue. You could just bring this part out to meet it. So this part will be slightly protruded. But it's just the base of the building is protruded a bit on the veranda to facilitate this part. Alright, so let's continue. Or it could be a case where the column, alright, give me a minute. Since the column is a bit wider than the thickness of the building, or the diameter is a bit larger, it can be like that. Now, the arch, let me show you a nice way to create the arch. I'm going to start the arch here, and the height of the arch from the lintel height, in this case I'll use 300, and then I'm going to bring it over here. There's no column over this side. Same thing, I'm going to bring it up. So I'm drawing it as a rectangle first, then up from here, and this is what I'm going to do. I'm going to take the arch command, click the starting point, the height, the ending point. Do that again for this side, arch, starting point, ending point. And I can now proceed to delete these. Now I have the arch. Let me remove these lines so that I can show you what is there so far. I don't need these anymore. Right, now it's looking like a front view. Alright, let's now proceed. If you notice, if you look through the opening, you will see the door here. You'll also see this window. So I'm going to project some lines, stopping it on the lintel height. So happens to be here, and this is an easy way to do it. Once the points are on the same level, you just copy this line to here and to here. So from here to the wall is the width of the door. From here to here is the width of the window. So I now know that I need to draw a door. Okay, something to mention quickly. Let me just do it quickly. The porch may from time to time be at a lower level, so I'm going to move these down, and that level in this instance is 100 millimeters. So basically the door, you will step up into the living and dining area, so that door will be a bit higher. Alright, so if you notice, you have to step up. It's not on the same level, the veranda, because oftentimes when it rains, the rain may blow on the veranda if the veranda is open, such as this one. So you don't want that water to flow in the living area. Alright, so the window I'll use the same 1200 millimeters, and it should come over this side as well. If you notice, a part of the window is hidden behind so I have to trim this portion. Let me just draw this, it will stop here. Alright, so I don't need this line anymore. I'm going to keep this line because I'm going to label this line as the height of the wall, or the height of the ring beam or the belt beam that the roof is resting on. Because, alright, the reason why I mentioned belt beam, when you're building a block wall, once the wall is complete, you normally top it off with a belt beam, which will support the roof whether it's a slab roof or a timber roof or any form of roof structure. All right, so we're almost done with the front view. I'm going to draw the windows now. Now, there are blocks that you can download online that represent windows. There are even some in AutoCAD. But what I find is most of the times these windows, they don't necessarily fit how I want them to fit, or they don't necessarily look how I want them to look. So you can go online and download, but sometimes you have to make some modification. But just in case you want to draw your own window, let me do something quick for you. So I'm going to click the offset command, and I'm going to offset the boundary of the windows by 50 millimeters. This is just a simple quick design. Now I'm going to fillet them to a radius of 0 so that they look like this. Alright, so that's the framing of the window. I'm going to now draw a line because the window has one fixed part, one movable part. Then I am again going to offset, but this time by 25. You don't have to go this complex. And this wall, if you notice, I did this from the center on each side. Here what? I'm going to do them a bit bigger. I'm going to use the 50 millimeters just the same. I'm going to do them one side at a time. Alright, this is what I should have done. Let me go again. Alright, so I'm going to offset 25 on each side. Because normally there's a sliding, when you have a sliding window, one window is slightly in front of the other. So once I've done this, I can now delete the center line. Alright, then I'm going to offset 50 millimeters this way and this way. I just wanted to ensure that this one was in the middle. I can now proceed to do this, and this. Then I can now proceed to mirror this portion over to the other side. You can redraw it if you want. So now this is creating the illusion that this part is in front of this part. Now you have a few tricks that you can use. This could be a simple glass pane. Let me change the angle to 45. Doesn't matter the angle, but 45 works for me. So you have a line in the middle, a line at the bottom that is shorter, and an even shorter line at the top. This simulates glass, and you can bring this over the other side. So that's one way you can draw the window. A second way, let me copy this. Let me remove this and this. You can just draw a line here, then a line here. Then you can measure this distance. This is 500, which means you're going to offset this line by 250, which is half, upwards and downwards. Then you can simply mirror this to the other side. Once you have this window, you can copy it. So it's all a matter. Alright, so this window space is 1200 millimeters, as you can see. If I measured this, you would know. This window is 1500. What I like to do is draw my windows ahead of time and then insert them in the space. So let me delete this line and let me delete this line. I am going to modify this window. So I'm going to move this side in by 150 and this side by 150. So once I do this, you realize that a total of 300 millimeters have been shaved off the window, and as such the window is now 1200 millimeters in width. I have some trimming to do, which is not so much hard work. If you notice, I'm using a lot of mirroring and copying. That makes the work easier. Then I'm going to simply just redraw another center line in the window, and there you have it. I have a window that is 1200 millimeters in width. The height of the windows for the most part remain the same. So I am going to now simply, I need this line to indicate where I should drop it. So I'm going to delete the rest of the lines. Then I'm going to copy, not move, because I might need this window again. I'm going to drop it here. That's where it was. If you notice, this is covering it is covering the column, and I'm going to just simply trim out the parts that are going to be hidden, and there you have it. I can do the same thing for the door. I'm going to just draw this door in space, 50 millimeters. The door is a bit easier if you're going to draw a simple door. Alright, so this is how you do the door. So this is the door, and you can the doors are better for download. You can download the door. If the size is a bit different, you adjust it to your size. Alright, so normally let me put a little circle here. Doesn't matter the size. Let me go 35. This represents the knob, and notice it's a bit lower than halfway based on how easy it is for your hands to get it. So now this is the door that is being shown. This is the window. Alright, I'm going to now hatch the front portion to simulate. I'm going to search for that roof plan, that roof hatch, or the hatch that would represent a roofing, the roof tiles. And this is it right here. I notice the size is very large based on the last hatch that I did. I'm going to change this to about 20. No, that is the angle. My apologies. The angle must be 0. This is the size, the scale rather. And that looks, let me bring it down a bit to 15. Alright, that is okay with me. What I like to do is to give my roof, I like to use the same layer on the roof for the roof plan as I did with the elevation as I did with the roof plan. It's up to you. Alright, so we are almost through here. Let me get this out of the way. Let me copy this and paste it here. This line, I'm going to turn this into, I'm going to change this line type. There are multiple ways to this, but I'm going to change it into a hidden line. I'm not seeing a hidden line, so I'm going to change the scale. Alright, I want it to be bright. I'm going to turn it red. I have to also turn this red. Alright, so these lines are showing the various layers, or levels rather. I don't necessarily need to indicate the lintel height as much, because in the sectional drawings I'll indicate that. Alright, so we're almost through here. Alright, this is how we normally do it. I'm going to draw a circle, doesn't matter the size, but let me use 200 millimeter, 100 millimeters as the radius. Then I'm going to draw a line going across and a line going up to separate it in 4. Then I'm going to hatch. This is the symbol to show levels, this part and this part, but with a solid hatch. Alright, I'm going to now take this, I'm going to place it here. I'm going to also copy this and place it up here. This is showing levels in elevation. Now I have these plans up here. I'm simply, in the interest of time, copying the labeling and renaming it. So this is the finished floor level. So after the tiling and so forth, this is the level of the floor inside the house. Then I'm going to copy this, place it up here, and I'm going to call it beam height. That is the height of the top of the wall, or you can call it top of wall, doesn't matter. Then I'm going to copy this and place it here and call it ground level. Alright, let me move this here, and that is it. This is your elevation. In some cases, persons would add dimensions to show the height, to show various heights like this, but they don't really go crazy on the measurements, because in the sectional drawings you will show all the vertical measurements that are needed for the builder to construct the building. You get all the measurements horizontally from the plans and all the vertical measurements from the elevations and sections. If you wish, you can also show the height of the roof. You can also write the slope of the roof. You can write pitch. The slope of the roof is referred to as a pitch. So roof pitch is equal to, in this case, 30 degrees, and the degrees sign is here in AutoCAD, and that's it. And this is the front elevation. Alright, so there will be a part 2 to this video, and in that video I will demonstrate how to draw a side view. I'm going to pick a side. If you notice, this is the shorter span of the building. The longer span, it will be drawn a bit, the approach for drawing the roof will be a bit different. So stay tuned for that, and I hope you learned what was taught here. There will be more videos demonstrating the drawing of elevations for more complex buildings, or in terms of the shape and the roof design. Alright, so stay tuned for that. Please like, share, and subscribe, and share the knowledge. Have a good day.